Bamboo is one of the fastest growing plants in the world. Some species are capable of growing 1 to 3 feet in a single day. During World War II, this extraordinary growth was exploited for a uniquely horrifying purpose. Japanese imperial forces reportedly used bamboo as a method of punishment against prisoners of war. Captives were restrained and positioned above young bamboo shoots. As the bamboo grew upward, it pierced through the victim's body. This brutal practice became known as bamboo torture. But bamboo is not defined solely by its rapid growth or its dark history. Today, it is often called nature's green steel, a giant grass whose fibers can, in certain applications, rival or even surpass the strength of steel itself. From the simplest objects, chopsticks resting beside a bowl, a straw in your drink, the toothbrush you hold each morning, to the floor beneath your feet, the chair where you sit, even the walls that shelter you. Bamboo is replacing wood, replacing plastic, reshaping entire industries. Its growth is rapid, its processing surprisingly simple. Its impact on the environment profound. And yet, few of us ever pause to consider the journey it takes. In this video, we follow that journey to discover how something so simple achieves what industry has long pursued. Strength, affordability, beauty, and sustainability. From the forest to the factory and to the world. You are watching Mighty Machines. Bamboo is no longer merely a symbol of ecological hope. It has become an economic force, a billion-dollar industry spanning continents and markets. As a material, bamboo is used for thousands of products across industries: consumer goods, construction, furniture, paper, textiles. Together, these sectors generate more than $70 billion each year. And the number continues to climb. Meanwhile, across the oceans, plastic waste continues its slow violence. Debris choking marine life, microplastics entering the food we eat, mountains of waste that will outlive generations. Against this backdrop, bamboo offers something rare, a material that grows quickly, renews itself, asks little of the earth, and gives much in return. The fastest growing plant on Earth. There's a reason bamboo is in such extraordinary demand. You see, bamboo grows unlike anything else on this earth. Under the right conditions, certain species can surge upward 91 centimeters in a single day and night. Just think about that for a moment. An oak tree, it might take 50, even 80 years to reach its full maturity. A pine tree, it needs 25, 30 years before it's ready for harvest. But bamboo? Most bamboo species, they reach full height, harvestable maturity, in just 3 to 5 years. Some varieties, even faster than that. But for all its promise, bamboo does not yield easily. China is the largest exporter of bamboo in the world. 8 million hectares now grow bamboo there, an area the size of Austria. Chinese farmers plant bamboo during the rainy season when the soil moisture is abundant. But first, they have to prepare the seedlings. They dig up sections of established bamboo rhizomes with buds attached, or cut young culm segments with nodes. These cuttings root in nurseries for 2 to 4 months. When it is ready, They dig holes 12 to 18 inches deep and wide, mixing compost into the soil. They place the rooted cutting at the same depth it grew in the nursery. Soil is firmly packed around roots to eliminate air pockets. They water heavily immediately after planting, then maintain consistent moisture for 4 to 6 weeks until new shoots emerge. In the next 4 to 5 years, the original cutting site will become unrecognizable. It will become the center of a bamboo grove, spreading 10 to 20 feet in all directions. Above ground, that single planting spot now produces 15 to 30 mature culms, standing 40 to 70 feet tall. This is the right time to harvest bamboo, but farmers cut only the mature culms. Experienced harvesters first wrap a ribbon on the culms that will be cut down. This selective harvesting removes mature culms while preserving young shoots and rhizomes, maintaining grove density, ensuring continuous annual yields, and preventing overcrowding that weakens overall bamboo health. After harvesting, workers strip away branches and leaves in swift strokes. What remains are bare culms, clean green poles tied into bundles of 10 to 50 stems using rope or wire. In steep terrain, trucks can't reach the harvest sites. Here, horses and mules navigate narrow paths, dragging bundled bamboo to roadside collection points. It's a method unchanged for generations. At the collection area, bundles are loaded onto waiting flatbed trucks. From here begins the race against time. These trucks transport the harvest to processing facilities where bamboo's transformation truly begins, where raw culms become flooring, furniture, or thousands of other products. The bamboo arrives at the sorting station within 48 hours of harvest. Time matters. Every hour untreated, the culms remain vulnerable to fungi and beetles. Workers separate culms by diameter and age. 3-year-old bamboo goes for scaffolding. 5-year specimens, thicker and harder, become structural columns. Inspectors run hands along each pole, feeling for invisible cracks. A compromised piece could mean collapse. What passes moves to treatment baths. What fails finds other purposes. Nothing is wasted. Approved culms move to the drilling phase. Workers use long augers to punch through the internal nodes, those solid walls that naturally segment bamboo every foot or so. This isn't optional. Without drilling, the sealed chambers trap air and block chemical penetration. Treatment would only reach the outer walls, leaving the interior vulnerable to insects and rot. Once drilled, culms are washed thoroughly to remove field debris, sap, and surface contaminants that would interfere with chemical absorption. Then comes the treatment tanks. Culms are submerged completely in borax boric acid solution for 7 to 10 days. The chemicals flow through the drilled passages, saturating the bamboo from inside and out, poisoning it against beetles and fungi. Without this step, construction bamboo wouldn't last 5 years. With it, decades. After treatment, the real waiting begins. Culms are stacked vertically, where air circulates freely. 6 to 12 weeks pass as moisture content drops from 60% to below 15%. What emerges is no longer just a plant. It's engineered material, drilled, treated, seasoned, ready to bear weight. The culms rejected for construction follow a different path entirely. The automatic machines operate like industrial surgeons. Bamboo is clamped onto conveyors. guided toward spinning blades, slicing each pole into dozens of identical pieces. Next, these culms are fed into splitting machines that cut them lengthwise. What comes out are long, curved strips, still bearing the bamboo's natural shape. Workers feed these through specialized equipment that planes away the hard outer skin and scrapes off the soft inner pith, leaving only the dense middle layer, the strongest part of the bamboo. The strips then pass through dimensioning machines that cut them to precise, uniform widths. Thickness planers shave them down to exact specifications, often just 3 to 5 millimeters thin. Finally, industrial sanders smooth every surface until the strips feel like silk. Heat treatment darkens bamboo to uniform color, while increasing hardness by 15 to 20%. Pressing laminated strips together under extreme pressure creates stable panels stronger than individual pieces, transforming narrow bamboo strips into wide boards with strength comparable to hardwood, enabling furniture manufacturing at scale. This is where bamboo's versatility reveals itself. These processed strips become flooring that rivals hardwood in durability. They're laminated and pressed into furniture, kitchen cutting boards, skateboard decks, woven into decorative panels. Other than furniture, bamboo is used for making cutlery items. Chopsticks are commonly made from bamboo in a quite similar way. After splitting, workers remove bamboo's hard outer skin, transforming culms into several feet-long sticks. These are bundled and tied, keeping them organized for the next stage. The bundles move to cutting stations where precision blades slice every stick to identical length, typically 25 centimeters. Consistency matters here. Uneven chopsticks don't pair properly, don't balance in hand. Next comes end shaping. Machines taper or round the tips while squaring off the grip ends. This happens in synchronized passes, hundreds of chopsticks shaped simultaneously with mechanical precision. From shaping, they move on to conveyors that pass through dedusting chambers. High-pressure air blasts remove sawdust and particles clinging to the wood. Finally, pairing and packaging. Chopsticks are matched, sleeved, in paper wrappers, and boxed by the thousands. The efficiency is staggering. Large factories process tons of bamboo daily, producing millions of chopstick pairs. Most cost mere cents. The transformation from forest offcut to finished product takes hours. But chopsticks are not the only cutlery item made from bamboo. Disposable spoons, forks, knives, and countless other utensils follow a different path. Workers cut thin, wide bamboo strips to specific lengths and arrange them in precise rows. Industrial laser cutters trace utensil dimensions onto each strip, spoon outlines, fork shapes, knife profiles. The precision is surgical, no waste, no human error. Once cut, the flat blanks are submerged in a stabilizing solution. This bath prevents warping and cracking. After drying, the flat pieces are placed into molds, each cavity shaped like the final product. Hydraulic presses descend with pressure at the right spot. Heat and pressure permanently reshape what was once flat into functional three-dimensional utensils. Now, we have biodegradable alternatives to plastic cutlery, shaped by machines, molded by pressure, ready to serve billions of meals before returning harmlessly to Earth. China exports millions of bamboo utensil sets annually. Hotels, airlines, food chains, anyone seeking alternatives to plastic cutlery that won't persist for centuries. But not all bamboo products require industrial machinery. In India, traditional methods still produce bamboo straws, using techniques passed down through generations. Artisans harvest 2-year-old bamboo culms, pencil-width diameter, the perfect size for drinking. These are cut into 6 to 10-inch lengths, each segment becoming a single straw. Disinfection comes next. The cut bamboo pieces are treated with salt solution, then submerged in boiling water. This dual treatment kills bacteria and removes any residual sap or impurities lurking inside the hollow chambers. After boiling, the straws are laid out to dry completely. Once dry, workers sand the exterior surfaces until smooth, eliminating any rough spots that might irritate lips. The interior walls receive equal attention, hollowed completely and cleaned until nothing remains but open passage. What emerges are finished straws, natural, chemical-free, ready for packaging. Each one slightly different in color and thickness, bearing the marks of handcraft rather than industrial uniformity. Plasticless Co. operates large-scale facilities in Vietnam while maintaining traditional methods. The company produces tens of thousands of straws with help of skilled artisan and mechanized assembly lines. Each straw remains chemical-free, passing through the same traditional steps, just faster, synchronized, and scaled to meet global demand while employing Vietnamese communities. Canadian company Lastic produces bamboo straws to reduce plastic dependence through industrial innovation. They process bamboo into their proprietary biodegradable fiber material called Lastic. This material is extruded through machines forming long, continuous pipes. The hot extruded pipes pass through cooling water baths for rapid formation and hardening. Finally, automated cutters slice them into standard straw lengths before packaging. Mass production meets sustainability. Traditional toilet paper drives catastrophic deforestation. Every day, 27,000 trees fall solely for toilet paper manufacturing. These trees required 30 to 80 years to reach maturity. Decades of growth erased in minutes just for toilet paper. Bamboo offers a radically different equation, harvestable in just 4 to 5 years, regrowing immediately from its root system without replanting. This makes bamboo the ideal material for sustainable paper production. Here's how industrial mills transform bamboo into toilet paper at a large scale. The process begins when harvested bamboo culms arrive at pulp mills and pass through industrial chippers, reducing them to small uniform pieces. These chips feed into digesters, enormous pressure vessels where they cook with sodium hydroxide at extreme temperatures. This pulping process attacks bamboo's lignin, the woody substance binding fibers together, freeing pure cellulose. Hours of cooking transform solid bamboo into fibrous slurry. The pulp then moves to washing stations where residual chemicals and impurities are flushed away. At this stage, manufacturers face a choice: use the natural brown pulp for unbleached paper or proceed to bleaching. This thin mixture sprays onto massive moving mesh screens inside the paper machine. Water drains through, leaving behind a wet fiber mat. The mat advances through heated cylinder dryers reaching 200 degrees Celsius. These rollers simultaneously press out moisture and compress fibers together. What emerges is recognizable paper: thin, soft, strong. Embossing rollers stamp those familiar dimpled patterns, adding texture while increasing softness and absorbency. The continuous paper web splits into narrow ribbons, then winds onto parent rolls weighing tons. These massive rolls transfer to converting lines, where precision blades cut them into household-sized rolls. Perforating wheels create tier lines between sheets. Automated packaging systems box the finished products. From bamboo chips entering the mill to packaged rolls leaving for retail, 24 to 48 hours. Modern facilities produce thousands of rolls daily, proving sustainability can operate at industrial scale. And that's all for today. From construction beams to disposable straws. You witnessed how bamboo playing its part. If you enjoyed this, subscribe for more videos exploring how industries transform everyday materials.